Hi, I'm Mr. V, and today's lesson from Illustrative Mathematics is coming from Unit 5 on solid geometry, and this is lesson number 9 about cylinder volumes. The goal for the end of this lesson is to be able to calculate volumes of solids that are composed of cylinders. So it's not as simple as just calculating the volume of a cylinder. That is something that's done in earlier grades. This would be the calculating a composite, a figure made up of one or more cylinders. And also to explain how to find the volume, how finding the volume of a prism relates to finding the volume of a cylinder. And if we can do these two things, you're doing pretty good for this lesson. So the first thing we had to do was we have these two shapes. One is a cylinder and one is a circular prism, not a circular prism, a cylinder. And we want to know what is needed to find the volume of each of these. Please write your answer in the space provided. I'm going to show you on my whiteboard how I would solve this problem. So the cylinder has a circular base. And if I were to draw this, I'll put it in dashed lines here. Let me see if I can do this in dashed lines. So this has a circle for its base. The area of the circle, the base of the cylinder, is pi r squared. The rectangular prism has a rectangle for its base. And its area, with a capital B, of the prism is the length times the width. Here we've got a length and here we've got a width. For the radius, we'll have a radius up here. Now both of these have a height, the height of a cylinder and the height of the prism. To find the volume is equal to the area of the base times the height. And that's true for both of these objects. They go straight up, so this would be the area of the base of the prism times its height. Well, what is the base? The base is pi r squared and times its height. For this one, it's length times width times height. So what do you need to be able to solve this? You need the radius, the height, the length and the width and the height. Or you could take the area of the base of either one of these times its height. And that will get you the volume. The next question on this is, so in previous grades, you were supposed to have learned these things or seen this before. And if this is the first time for you to see it, I'm sorry, because this is not, the 10th grade activity is not just to write the formula and substitute the values. There's more to it at the 10th grade level to dealing with the prism volumes and cylinder volumes. So in previous grades, you were supposed to have learned this. And if you didn't, it's pi r squared times the h. The pi r squared is the area of the circle. You're going to be asked to explain your reasoning and to be clear about your language. So here are two containers. All the measurements are in centimeters. Suppose the prism has a height of water that reaches 1 centimeter. Can you draw that on the figure? What would that look like on this figure in this situation? And then you pour the water from the prism into the cylinder. And we want to know what is the height of the water in the cylinder and to explain your reasoning. So this is not a matter of guessing. This is a matter of actually doing some calculations. I'll move my picture over here a little bit. The water level, if I were to draw it, it's going to look something like this. I'm not drawing this to scale, of course. This height here is going to be 1 centimeter. And when you dump it in over here, it's going to be going all the way around, and this height is going to be some height of the cylinder. We don't know what that height is. That's what we're looking for. We're actually going to try to find this. When we do this, I'd like to point out to you that the cylinder has a circular base, and the rectangular prism has a rectangular base. We can also write our formula. The formula for the volume of the cylinder is the area of the base times its height. And the volume of this prism is equal to the area of its base times its height. And these two are equal because I'm taking the water from the one and dumping it into the other. So the volumes that I have in the one should equal to the volume of the other. Well, what is the area of the base here? The area of the base of this is pi r squared. So it's a circle. So I have pi times 6 squared, which is 36 pi square centimeters. I'll leave it in terms of pi. I don't need to go any farther than that. For this one, the area of the base of the prism is the length times the width, which is 4 pi times 9, which is 36 pi centimeters squared. These are the same. So when I substitute these values in, I get the volume of this one is 36 pi times my height, which is h sub c. When I substitute this in, I get 36 pi times 1, because my height over here is 1. And you'll notice that these are the same, so what I'm multiplying it by should also be the same. My height here is going to be 1 centimeter, and I'll circle my answer. Now, if this were 3 centimeters, my height would also be 3 centimeters. Why? Well, it's because the area of the bases are the same. If the area of the bases are the same, it's going to be the same all the way up. So if I'm going up 1 centimeter, I'll go up 1 centimeter here. It isn't always going to be the same, but it is in this case because my areas of my base of my prism are the same. And the idea here was to look at these, describe what the volume formulas you used. Maybe you used pi r squared h, or length times width times height. I used the area of the base with a capital B times the height. And since the area of the bases were the same, the heights had to be the same as well, if we were talking about the same volume being dumped into the other, one into the other. And this could be true if it was a pentagonal base or if it was a hexagonal base. If the areas were the same, it's going to be the same all the way up for a prism as it is for a cylinder. A cylinder can be thought of as a prism. It's not. A prism has rectangular sides. Now here we have a figure. We're supposed to sketch this when we do a rotation and then find the volume. And I'm going to do this one for you and the next one. So here, if I were to take this solid and rotate it, this point to the right is going to go same distance to the left, same here and here, and same down at the bottom. So when I rotate it, it's going to look something like this. And I'm going to try to draw it like a circle as best as I can, like a circle that's been squished down, because it's and I'm drawing this one dotted because it's behind the figure. You can't see it. Here we have this one in front, and this one I can also see up until the point that it reaches this. So I'll draw this in dotted lines. And then this is solid going down, and I'm going to draw this going down like this. And it'll be dotted in the background. Can you see I have 2 cylinders, one on the top, one on the bottom? Well, the volume of the first cylinder, when I add it to the volume of the second cylinder, I will get my total volume. And that's what we're looking for. So this is my formula. Of course, the volume of a cylinder in general is the area of the base times the height, or it's pi times r squared times the height. Well, the radius of this first one is 2. The height of this first one is 3. Is this something that you could do? Yes, it is. You could do this. The radius of the first one is 5. The height of this first one is 3. So when I substitute these values into this formula, I write pi times the radius, 2, squared, times the height, 3, plus pi times the radius squared, which is 5 squared, times the height, 3. 2 times 2 is 4, times 3 is 12. So this is 12 pi, and this is going to be 5 times 5, 25, times 3. 3/4 is 75 pi. My answer is equal to 87 when I answer this, 87 pi centimeters cubed. And if you wanted to multiply it out, you could, but this is the exact answer. This is good. I'm interested in this. The next question is like it, only it's got a different one. So you see, I'm not talking about the volume of a cylinder. You have these composites. It's made up of one or more cylinders or one or less cylinders, like this one. When I rotate this around this axis, my points are going to end up here and here, and down here and here. My height of this is 6. When I rotate it around this one, I'm going to get this big circular thing, trying to draw it as best as I can. And I'll do this one. This goes down as solid, and I can see it solid at the bottom all the way down. This one here, though, is on the inside, so I'll draw it dashed. I'm going to draw it dashed going around this way. And same with the line coming down. This is seeing through it. Can you see that I've got this solid outside cylinder, and this inside, it's empty. There's nothing there. It's like air. So I really have two cylinders. I have the big one, and I have the little one on the inside that I'm going to subtract. My formula is going to be the volume of the one minus the volume of the other. And of course, the volume of a cylinder is equal to pi r squared times h. This is the area of the base times the height. The area of the base is a circle. Well, what is the radius? What is the height? What is the radius of the second one and the height of the second one? Both of these have a height of 6. The radius of my first one is 5, and the radius of the second one is going to be 3. So when I substitute these into the formula, I get pi times r squared, which is 5 squared, times 6, minus pi times 3 squared times 6. Well, 6 quarters is $1.50, so that's 150 pi minus 9 times 6. 10 times 6 is 60. 9 times 6 would be 54 pi. When I subtract these, I get 96 pi centimeters cubed, because this is in centimeters and it's a volume, so it's cubed. Can you see that that's what this would be? Do you picture this in your mind? Can you draw this volume of a rotation? I will be asking you to do that on our test for this unit, so make sure that you know how to draw volumes of a rotation. Sometimes they're called volumes of a revolution because it's like a revolving. And here's a question. Given a cylinder with a radius of r and a height of h, write an expression for the volume. If each of these changes were made, if the height was tripled to be volume 3 times the height, if the radius is tripled to be 3 times the radius. So let's do that. The original formula is going to be the volume is equal to pi r squared times h. And in the first one, we're going to substitute h. We're going to substitute it with 3h. We're going to scale this up by 3. So when I plug in this for h, I get volume is equal to pi r squared times 3h, or 3 times pi r squared h. I'm scaling up one of the linear factors, and so the whole volume goes up linearly. It goes up by 3. What if instead we tripled the radius? So I'm going to substitute for radius. Every time I see r, I'm going to substitute in the value of 3 times the radius. I'll do this in blue so you can see the difference. Well, my volume is equal to pi times 3 times the radius squared times the height. This is pi. 3 squared is 9 times r squared times h, which is 9 times pi r squared. It's 9 times my original volume. Why? Well, the r, the radius of this cylinder, has both a length and a width component. It's r squared because it's got like the length and the width versus the height. So it's like taking an area, and the area is proportional to the k squared. And it is same here. I'm squaring this piece of it. So I'm not just, here you're only multiplying this 1 by 3. Here you're multiplying 3 times 3. So this is 9 times greater. Well, what if you did this to a cube? If I had a cube, it's going to be a side length of L, W, and H. My volume is equal to L times W times H. And if I were to triple the side lengths, so I'm going to do 3L times 3W times 3H, or 3S times 3S times 3S. It's going to be 27 times larger than the original. Which one is the most? The cube. I'm cubing all 3 dimensions. In the cylinder, when I do the radius, I'm doing only the the radius, I'm doing that in 2 dimensions. I'm going to do the height, it's only 1 dimension. So this would be 3 times larger, 9 times larger, and 27 times larger. Now, the last thing for us to do in this lesson, well, there's 2 more things to do. Here we have some objects, and I should do this on my whiteboard. I have some objects. And which one of these could you find the volume of the formula using volume is equal to the area of the base times the height? Of course, it would have to be a cylinder or a prism. It looks like the pen is pretty close. I mean, it's got a hexagonal side over here and circular here, really. But it's, if you think about this as being a prism, this could be one. Stick of butter, definitely. Maybe the screw is kind of like a cylinder all the way up to the bolt. Excuse me, this is not a screw. This is a bolt and a nut. The bolt would be, the nut might be, if you think of it as being a prism, a hexagonal with a circular center cut out. The ball, no. The cone, no. And this pyramid, are you familiar with this pyramid? Have you ever seen this before? This is at the Louvre in Paris. It's in front of a very old romantic building. And im.g.5.9.cylinder was chosen to design this. If you've seen the movie The Da Vinci Code, I think it appears in Da Vinci Code. When this first came out, it was a scandal. It was a big scandal. They thought, how can you ruin this great masterpiece of art that we have, this, putting this big pyramid in front of it? But actually, it takes the ancient pyramid stuff, and they have an obelisk that they took from ancient Egypt that they had in front of the Louvre, and here he is just contributing to it. This is an ancient architecture, and he's making it modern with all the glass. And so it's actually now iconic. People recognize this from all over. So this is pretty cool. And then I have a question here for cool down. So Jada says she used the formula volume is equal to the area of the base times the height. That's good. Andre says he took the area of a cross-section and multiplied it by the height. Well, that's good too. The area of a cross-section would be a circle, pi r squared. Hans said I used the formula volume is equal to pi r squared times the height. Pi r squared is the base. And if you got that, well, you're good. So that's the big idea for the lesson for today. Good luck and success.